late or don't get what they need to get. While you're waiting for Miss Neville to set up our gorgeous lab today, you're going to be copying down this lab report. Now, you were supposed to do this yesterday because there was no live session. But if you didn't, you'll need to be doing it now. Miss Neville will start our notes today in 4 minutes. Give me 1 second, guys. I want to admit some kids in. So today we're going to be talking about what air pressure is. It's really important for us to understand air pressure, especially when we're talking about the troposphere. We want to remember that the troposphere is the layer of our atmosphere that's closest to our Earth, okay? And that layer is so important because it has gases there that's able to sustain our lives. Weather occurs here. Hot air balloons and airplanes fly there as well. We also want to make sure we understand the relationship between altitude and temperature. Remember, altitude is the height from sea level. So the higher we rise into the sky while we're in the troposphere, the colder we become. Yes, the temperature decreases or goes down. So as we're looking today, to work on understanding altitude and temperature, Miss Neville wants to kick it up one more notch, and we're also going to introduce air pressure today. Remember, as altitude increases, pressure decreases. Temperature decreases. And what we want to understand here is that the higher we go up in the sky, the colder our temperatures become. So as we're looking in our notes today, let's write down in our notes, what is air pressure? What is air pressure? It's important for us to understand, you don't have to draw the picture, you do need to write the answer to this question. Air pressure is the weight of our air, or gravity, that pushes down on us and all things on Earth. So as we discuss air pressure, it's important for us to understand that gravity is pushing down on us constantly. We're going to be able to see today that the size of an object determines how much air pressure needs to push down on us. Give me 1 second, guys. I'm sorry. Okay. So air pressure is the amount of air that is pushing down on us. So you don't have to draw anything here. You don't have to write anything here. If you want to take a moment to go get your crayons and color pencils, you should, because you're going to be drawing some pictures today. We want to make sure that the amount of air pressure that pushes down on us is determined by how heavy or how big we are as an object. So over here on the right side, we see a heavier person. Please mute yourself. We see a heavier person. So this heavier person needs a lot of air pressure to push down on them. Yes, a lot of gravity needs to push down on this.
Calm down.
Please mute yourself. But with a smaller person or object, less air pressure needs to push down on them. So that's the relationship between mass, how big or heavy an object is. That's the relationship between air and air pressure and mass of an object. So when we're looking, we want to talk about, while we're looking at this, we want to be able to talk about how important air pressure is, because it has something to do with the weather in our Earth. So let's keep looking here. Let's talk about the pressure, air pressure's relationship, what it has to do with temperature. To do that today, we're going to do a lab, a can crush lab, okay? So let's look at how we can illustrate this relationship doing our soda can lab. So in your notes, you should have this lab report made. In the information that you see here today, while we do a lab with a soda can, what Miss Neville has here, let me turn you so you can see me. What Miss Neville has here is a can, an empty soda can with water in it, and an ice bath, okay? What I've been doing is in this empty soda can, I've been heating up a little bit of water, about 2 tablespoons of water, and I put it on a hot stove eye. I'm going to practice some lab safety. turn my eye off. Step 2, step 3, I wanted that water to begin boiling inside of my can. You can't see this or hear this, but I hear the water boiling inside that can, and I see the smoke coming out of this can. What we want to look at today is this can is extremely on the inside and on the outside. What we want to be able to see today is what will happen to my can if I drastically change the temperature of this can. So what I'm going to do, step 3, is I'm going to use scissors to pick up my can and carefully flip it over into this ice bath. So what happened here? Our can crushed. You see it? And it soaked up some of the water inside of my ice bath. What we're going to do in our data chart today is fill out what happened. Our can is completely crushed. It's not hot anymore at all. Ms. Neville can touch it. And we're going to talk about what we saw happen and why we saw it happen today. So, with our can, we saw some changes occur. And when we're looking at our lab report, we want to be able to look at, when we're looking at our lab report, we want to be able to fill in our data chart. Before I put that can in that ice bath, it was 100 degrees Celsius. That water was boiling inside, and my can measured 6 centimeters wide. My can, before it crushed, was 6 centimeters wide. Then, after I flipped it into that ice bath, we saw the can's temperature decreased to 30 degrees Celsius. And the width of the can decreased. It went from 6 centimeters wide to 4 centimeters wide. Yeah, that can got completely crushed. So our hypothesis, our educated guess here, we should have had some answer where we talked about what we thought would happen to the can if that temperature decreased. So we could have written here, if the temperature decreases, then the can will explode because but that can didn't explode because, okay, that can will explode because the air pressure is so great. Now, is that what happened, guys? Did my can explode when I made it colder? Turn on your mic and let me know. No, it didn't. So that means my hypothesis was incorrect. If you'll look there at the bottom of our screen, and I'm going to make it bigger. Okay. The hypothesis was incorrect because the can crushed. Our can became crushed. So my hypothesis was incorrect because the can became crushed. Yeah, I didn't get more air pressure when that can got cold. I got less air pressure because that can got cold. So the relationship that we see there is the higher the temperature, the higher the amount of air pressure. The lower the temperature, like that ice bath, when I put that hot can in there, the lower the temperature, the least amount of air pressure. And we're going to draw that in our notes today. Please take some time to finish your lab report. Miss Neville is going on in 3 minutes at 1:27. You've got about a minute left. So what we want, and this lesson is being recorded if Miss Neville goes too fast, okay? What does this mean? What does this tell us? Well, let's write in our notes the relationship that we see here. You're going to see Miss Neville use some abbreviations today. Whenever Miss Neville writes the letter A, I mean altitude. Altitude is the height from the ground, okay? You're going to see Miss Neville write the letter T for temperature. You need to write this down as well, babies. And you'll see Miss Neville write down AP. And what do you think AP stands for? Someone turn on their mic and let me know.
Air pressure.
Air pressure. So what we need to make sure we understand here is as temperature increases, air pressure increases. That's true with our can. When that can was super hot, boiling on that eye, the pressure in that can was big. If I would have kept boiling that can, it would have exploded, okay? So the air pressure increases as the temperature increases. So the opposite is true too. Somebody finish my sentence for me. So as as temperature decreases, what happens to air pressure?
It also decreases.
It's also going to go down. I hope I fixed it. I hope you can see that's an A and not an E. You need to be writing this down. So as altitude, the higher we go into the sky, our temperature goes down and our air pressure goes down too. Remember, air pressure is like that annoying little sister. It's going to copy whatever you do. So if temperature goes down, so will air pressure. If temperature goes up, so will air pressure. And we're going to draw a picture over here, or at least Ms. Neville's going to attempt to draw a picture. And I want you to draw it as well. Black this time. Okay. So let's create a little chart here. I don't like that line. Hold on. Here we go. Okay. Before and after. So what we're going to see today, what we're going to be able to see here is that can, please forgive my drawing, can, Lord. Hush, it's a can. So as we see this can here, that can was super hot. Because that can was super hot, the air pressure was building and it was really strong, okay? The temperature was high and my air pressure was high. But then, all of a sudden, my can became crushed. If you can draw it better, please do. So our can was crushed. Okay. So that meant what happened there was less air pressure. My air pressure decreased. My air pressure decreased. Okay. And that was because we introduced that ice, okay? So as my temperature decreased, so did my air pressure inside that can. That's why it got crushed, okay? A little bit of air pressure here, just a little bit, not much. I'm gonna do some little bitty blue arrows here. That's why that can became crushed. Please take some time to finish drawing this picture as well. You'll always see Miss Neville represent heat with red and cold with blue. That's because it's going to be really important when we start talking about weather and air pressure systems, that you understand the role of hot and cold here, that you understand that convection is occurring. Miss Neville is about to go on. So as we understand air pressure, we want to also make sure we're understanding how powerful heat is and how powerful cold is. How they are so important and how they interact with one another when we're talking about weather. So what we're going to do today in our notes is we're going to keep moving with our notes about the water cycle. In your notes, these are new notes. In your notes, if you would please write down the water cycle. You do not need to write down the learning objective. This is just so you understand the role of our lesson today. It's important for us to understand that the water cycle is something that we should have learned as fourth grade scientists, and we're going to be able to understand the role, the job of the water cycle with weather. We're also going to be able to see how important convection is. Convection. Can someone tell me, turn on your mic and tell me, what does the law of convection say? Heat will always
move up, and
rise, and cold
the
will
cold will
always
always move down.
sink. And can anybody remember why? Think about Miss Neville and you on a seesaw. Why would I go down first?
Because the cold is more dense.
Very good. Cold is more dense, cold is heavier. So when we're talking about the water cycle, we're going to see how convection plays a role. We're going to be able to see convection illustrated or shown here. So the water cycle. Things to remember. You do not need to draw this picture. You can't really see the words. Things to remember here. Please write down the law of convection. Heat will always rise and cold will always sink. And isn't that what we see happening in this picture here? That hot water is turning into water vapor and it's rising through evaporation. And when that water gets cold, it sinks and falls to the ground as precipitation. Absolutely. Babies, it's important for us to understand that the law of convection is the reason, it's the reason why the water cycle works. It's the reason why the water cycle works. Ms. Neville is about to go on. So in your notes today, you're going to be able to pause our video when I release it. As soon as we're done with class, I'll release it to your Schoology blue folder. You're going to be able to draw this picture today. And I want to kind of tell you what we need to be labeling in this picture today. So please use your colors to label and pay close attention to what you need to label. So we want to make sure we draw this picture of the mountains here, but we also want to make sure that we label it the mountains. We want to make sure that we label evaporation happening here. This is our ocean. Lakes, all lakes eventually pour out into our ocean. So we want to make sure that we have both the ocean and lake labeled. We're going to be introducing a new step in our water cycle called transpiration. Transpiration, I like to affectionately think of it as plant sweat. It's important for you to know that when plants get hot, water is released from them as well. Transpiration is plants releasing water, water that they soak in from their roots, comes out when the water gets hot and it's released as water vapor or steam through its leaves. So when we're thinking about transpiration, we're thinking about plant sweat. Okay? Plants sweating. When humans sweat, we call it perspiration. When plants sweat, we call it transpiration. Evaporation and transpiration both need heat in order to work. So they both happen at the same time because they both need heat to work. And we're going to go more into this on Monday when we're discussing this, but it's important for us to understand. I want us to have those arrows that where the heat is rising, they need to be red, not blue, okay? That heat is rising. Those arrows need to be red, not blue in our notes. But then what happens here during condensation is this is where clouds are made. Clouds, when that water vapor gets up to the top part of that troposphere, remember it gets cold the higher we go into the sky, right? So as we're looking here, those ice crystals, that water vapor turns into ice crystals, and those ice crystals mix with dust in the air to make clouds. Okay, ice crystals mix with dust in the air to make clouds. So when that happens, we're then going to be able to see our clouds here as they start to become lower to the ground. We're going to see their altitude decrease. They're becoming lower to the ground. That water, those ice crystals will start to warm up. Oops, sorry, y'all. Those ice crystals will start to warm up and precipitation will happen. Condensation is step 2. Precipitation, which is rain or snow, is step 3. That water is going to run down, run off, and fall down the hills. It's going to fall down those rocky layers of the mountains. And then our final step here, and this is groundwater runoff. Step 4, groundwater runoff. So you're going to be finishing this picture in your notes. It needs to take up a full page in your notebook. Okay, you want it to be big, you want it to be labeled, you want it to be colorful, because I promise you're going to need this chart later on. Hint, hint, hint. Okay, so that is our Thursday class for today. If you did not finish this picture or any part of our notes, this lesson has been recorded, so you'll be able to watch it through Schoology as soon as I release it. Please have an amazing day. If you have any questions for Ms. Neville, please don't hesitate. Please don't hesitate to reach out to me through email. Goodbye, guys. Have a really great day.
Bye.